One common practical application of acid-base chemistry is the technique of titration. And what this is, titrations in general are a way of using a chemical reaction to measure concentration. Acid-base titrations are the most common type of titrations, but there are other kinds of titrations that are present as well. But all of them rely on some kind of chemical reaction. In this class, we're only going to focus on acid-base titrations. If you ever take analytical chemistry, you'll get to explore other types of titrations. But the basic idea of titration is that we have some sort of solution, so this could be an acid or a base, that we put into what is called a burette. This is a way of measuring concentrations very precisely. And then in our solution, we have some unknown chemical. Not unknown in that we don't know what it is, but unknown chemical concentration. So generally we know that there is something present that is an acid or a base, but we want to know how much of it there is. What's the molarity of the solution, back to that idea of concentration. And so usually what is in the burette is a known concentration of a strong acid or base. And then our unknown will be the opposite, whether it's acid or base. So if you want to measure an unknown base, for example, then what's called the titrant, that is our solution up here that we know the concentration of, will be an acid, a strong acid, and we would flip-flop those if we wanted to measure an acid that's our unknown chemical concentration. We would use a base as the titrant. And so this is the basic idea of a titration, is that we use the chemical reaction. Now, how does this work? How do we use the chemical reaction? So let's think of it this way. Let's pull this up here. So our unknown, let's go with this being a base. Our unknown is present as a base in our solution, and this has some unknown concentration. But there's a certain number of moles of base that's present, and that's what we want to know. Right? If we know the number of moles of base, then we can go back to what the concentration of the original solution is by taking our moles divided by volume of the solution that we started with, and that will give us a concentration. Great, so that's the basic idea. But how do we know how many moles of base there are? Well, what we do is we we can measure how much acid we need to add. So we'll add acid to the unknown. That will react with the base. And we have some way of keeping track of when this reaction is complete, when all of the base has reacted with acid that's added. And we keep track of the reaction. Now, how do we do this? We use what's called an acid-base indicator. And this is a molecule that will change color once the reaction is complete. So a very common indicator that's used for many acid-base reactions is a compound called phenolphthalein. It's a mouthful to say and a mouthful to write. But one example, and there are many acid-base indicators, this is just one example, is phenolphthalein, is how it's spelled. And this turns pink when the reaction is complete. And so in a titration, you add just enough of your titrant to cause the indicator to change color, and that's when you know you've completed the reaction. And one of the fun things with titration is you have to get just enough of your titrant added to cause that color change, because if you add too much, then you've gone past the end point of the reaction. And so the point at which your indicator changes color, this is called the end point of the titration. And the goal is that your endpoint should be the same as the equivalence point, which is where your moles of acid and base are balanced out according to the stoichiometric ratio based on the reaction equation. For many acid-base reactions, these are one-to-one stoichiometries. 1 mole of acid reacts with 1 mole of base, but not for all of them. Sometimes you need 2 moles of base to react with a mole of acid, or vice versa. or 3, or depends on the stoichiometry of the equation. So that is the goal that we're trying to reach. So the whole point of this, of course, is we want to know how many moles of our unknown do we have, whether that's base or acid. It's going to depend on the specific titration we're looking at, and then use that to find a concentration by knowing the original volume of your solution that you started with. So this is a general conceptual overview of titrations. In the next video, we're going to look at an example of how do we actually calculate concentrations given some data.